Okay, we're ready for video 39, Math 108. I'm sorry, Math 105. So, we are still talking about synthetic division, but we're going to show it to you again, but along the way, teaching something else. Let me explain exactly what I mean. All right. So there's such a thing as evaluating a polynomial. As soon as I show you that that's evaluating any function, you're going to see right away that it's no big deal. Evaluating a polynomial, just like evaluating any other function. So give me a chance. Hold on. Evaluating a polynomial. And then after that, okay. Then we're going to be talking about something that sounds pretty fancy. The remainder theorem, it should be an E, that's an E-O-R-E-M. We're going to be using the remainder theorem to evaluate a polynomial. Right? Just bear with me to evaluate a polynomial. Okay, now let's intro. Let me give you a polynomial, problem number 1, and it's going to be a little bit long. F of x equals x to the 4th plus 6x cubed minus 12x squared minus 30x, no gaps, right? It goes from 4 to 3 to 2 to 1, plus 35. Okay, and here's what we're going to do. I'm going to ask you, what is f of 2? F of 2. All right. So now, if we do it the old-fashioned way, right? F of 2, the old-fashioned way, right? Old-fashioned way to evaluate. So this is what we're going to do. This is what the old-fashioned way equals 2 to the 4th plus 6 times 2 to the 3rd minus 12 times 2 to the 2nd minus 30 times 2 plus 35. Okay? 2 to the 4th is 16. 2 to the 3rd is 8. 6 times 8 is 48. Okay. 2 to the 2nd is 4. Minus 12 is minus 48. All right, 4 times 12 is 48, so it's minus 48. And minus 30 times 2 is minus 60 plus 35. Okay, how much is that? These two cancel each other out. 35 and 16 is 51. Minus 60 and 51 is equal to minus 9. That's the old-fashioned way. That's the old-fashioned way. Now, the remainder theorem. Using the remainder theorem to evaluate a polynomial. If we take the polynomial, we're going to take this polynomial, take our original polynomial, and and we're going to take the original. Let's take the original. Take original polynomial from the question. Original. Divide it divided using synthetic division by 2. What were we asking for? 2? Let's use synthetic division. All right, let me show you what I'm talking about. Got to move this up. Okay, here's our plan. So this is a 1. The coefficient of x squared is a 1. The coefficient of x cubed is a 6. The coefficient of x squared is a minus 12. The coefficient of x is minus 30. And the number is 35. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is 35. Do our little L for synthetic division. And we're going to put the number 2 in the upper left-hand corner. Number 2. And let's see what happens. Bring down the 1. 2 times 1 is 2. 6 and 2 is 8. 2 times 8 is 16. Minus 12 and 16 is 4. 2 times 4 is 8. Minus 30 and 8 is minus 22. 2 times negative 22 is negative 44. And 35 and negative 4 is negative 9. The remainder, that's why it's called the remainder theorem. The remainder, it's called the remainder theorem, right? Remember we called it up there, it's called the remainder theorem. The remainder theorem. Okay, the remainder right here and that are exactly the same. So there's another way of producing negative 9. The old-fashioned way to evaluate f of 2 is to go all the way and get negative 9. You can also take the original polynomial, divide it using synthetic division by 2, and we will get the evaluation. We will get the evaluation of f of 2 by way of the remainder. So the remainder theorem can get you that same evaluation using synthetic division. That's what we're trying to say here. And that's what this video is all about.